Earlier this week, my wife and I posted these photos to our Instagram. That's us as Batman and Catwoman, Mr. and Mrs. Smith, and the Man in Black and Dolores from Westworld. These are all AI-generated images, and with this technique, I can have us as Barbie and Ken, Jack and Rose, or just about anything. Not only that, but this technique finally allows us to make images of any scene with multiple characters consistently. So today, I'm going to show you how it all works and how you could put yourself in any scene, whether that's a movie, a video game, or something entirely out of your imagination. Anyways, I'm super excited. I know you are too. All right, let's go. To generate images, we need an AI model, which I recommend FLUX because it produces the most realistic looking images, and it's probably the smartest when it comes to understanding prompts. FLUX is free and open source, so you can get it on Hugging Face. We also need a method to tell these AI models, hey, this is actually what we look like. And in order to do that, we use something called LoRAs, which is short for low rank adaptation. LoRAs help you customize AI models to learn things like characters, styles, environments, and a whole bunch of things. So to create a LoRA that's specifically trained on yourself or yourself with another person, you're going to want to have a decent data set of images that actually include yourself and multiple people as well. So for these images, I first went ahead and compiled some photos of myself in front of this vanity mirror, making sure to have really great and even lighting across my face. And it also helped that I had a fresh fade haircut from Chriselle, because that is essentially what hairstyle is going to get trained into this model. Then I had Chriselle also do the same exact thing, and I ended up pulling photos from us that were in the wild on our Instagram, and using this as training data also helped it. So by the end of it, I have some photos that are just me, some photos that are just Chriselle, and then some photos with both of us together. Now, the way that we distinguish which photos are which comes into how we train this model. So we're going to be using Civit AI, which is a super easy and awesome tool to go ahead and train LoRAs. It's as easy as just uploading the photos, giving it a couple tags, and then hitting train. One thing to note though about the tags is that I'm not even going in and detailing them super specifically, because a huge part of this is assisted by AI captioning, which will actually look at each photo, generate a description of it, and all I have to do is go back in and add in my name so that it says Nate or Chriselle. And as long as I have these descriptions in there along with the tag and the trigger words of Nate and Chriselle, the model should be able to distinguish which photos are which person. And once we finally have ourselves together in a photo, it's also going to be able to distinguish which person is which. This is going to be super critical when it comes to creating an AI generated image with multiple people. Civit AI though is not completely free to generate your own LoRA. It is going to cost probably about $2 per LoRA trained. So if you do have a really strong and powerful computer, you can actually train LoRAs by yourself for free using a tool like FluxGym. Your results may vary though. If you've done everything all set up though properly, you should have a working LoRA, and all that you need then is a method to actually implement this LoRA. So I first started using ForgeUI, which I will link down in that description, and I recommend it for beginners because there's not really a whole lot of different playing around and settings to mess around with. It's pretty easy to go with, and off the bat, you're gonna get up and running pretty quickly. Whereas if you are someone that is a little bit more advanced or intermediate and have maybe worked with a software like After Effects, Blender, or Photoshop, then I highly recommend that you dive into ComfyUI, which is what I use to generate these images. Both tools are great, but to give an analogy, ForgeUI is like having iOS or an Apple iPhone, while ComfyUI is like having an Android or a Samsung S24 Ultra. So I'll let you guys go ahead and be the judge as to which tool you want to use, but for some of the more complex sections, most of those features are only going to be available in ComfyUI. So this is what the workflow looks like. There's a whole bunch of mess going on here, but to make things easier, we're going to break this down one section at a time and go on from left to right. So starting here on the left side is where we have our step 1 area, and this is where we load in our AI model, which is also called a checkpoint. This next area here on the right is where we can load in a reference image, and you can see I have a still here loaded in from the newest Batman movie, which shows Batman and Catwoman. And then down here below, we have our area where I can set LoRAs. So here I have the Nate and Chriselle epic mix, and I'm gonna leave the strength model and clip model values at 1, which stands for 100%, and this is essentially how strong the LoRa will be applied. If you crank this value too high, the image might break, and if the value is too low, it won't look like me or Chriselle when I generate the image. Another thing that you're going to see here is another LoRa loaded, which is actually a LoRa created by someone else. It's called Realism, and this one only has a value of 0.2, which is 20%. And the reason for that is because we don't want this LoRa to alter how we look too much in the generation. This LoRa is specifically trained to add more details such as skin textures, fix hands, and otherwise add lighting. At the bottom, you don't really need to worry about this section here because this is just where I save prompts that I've enjoyed before. I have a little node here that lets me change different prompt words and replace them much easier and on the fly. If you're curious what these semi-transparent purple nodes are, those are deactivated, and I can turn those on and off with Control B, but I'll leave these off for now. Next here in the middle section is where we actually have the main prompting area. This is where the meat and potatoes is. So you can see we have a prompt that says a cinematic movie still of a black man and a Filipino woman, Nate and Chriselle. Nate and Chriselle are wearing matching superhero outfits. Nate is wearing a tight-fitting tactical Batman-inspired suit with a cape and utility belt. Chriselle is Catwoman wearing black leather tights and a neck collar. So yeah, I'm not going to read the rest of this, but I think you can kind of get the gist of the prompt, which is that for prompting in Flux, it's unlike some of the other AI generators that you may have seen before where people just use a bunch of commas and keywords. Instead, Flux prefers for you to actually type out your sentences like you would in Author and really direct the scene. One little quirky thing that you may notice in there is that I have race and gender identifiers in the prompt, and that's because we're dealing with two people. So sometimes you may find that your characters are blending into each other, and I found that it helped to give some sort of generic identifier to help the AI model distinguish which character is which. In this case, I'm using race and gender. Now again, Flux is still better than most AI models in its understanding, so oftentimes I can just refer to myself as Nate instead of a black man Nate, but this is just something that I've also seen to help, and your results may vary depending on what characters you're trying to generate and what scene that you're going for. In this next section, you'll see we have a bunch of nodes here. Some of these are turned off. These are my control net settings. If you're curious what a control net is, control nets are what we can use in addition to LoRa's to guide image generation. So here you can see this actually has a depth preview, which means that the brighter areas of the image are closer to us while the dimmer areas are further away. So the LoRa says to Flux, here's what Nate and Chriselle look like, and the control net says make them in this specific pose or compose the photo like this. A nice analogy is to think of LoRa's like your concept artist and control nets like your director. If both of these can work together, it's pretty easy to make something special. So I specifically used the depth control net to influence this generation, and I had it kept at a really low value of about 0.3 or 30%. The reason being is that if I was to crank this value up too high, Flux would have a really difficult time generating me as Batman and my wife, Chriselle, as Catwoman, because instead it would try generating the exact frame and outline that it was given based off of this depth map. So make sure when you're using a control net or a depth map to influence an image that you make sure that you have your values set to somewhere probably below 35%. That way you don't end up with the same exact shape as your reference image, and instead you have your bodies from the LoRa's that you trained earlier. If you're curious what these values here are, this is clip text encode, which is what takes our prompt and translates it into something that Flux can understand. The clip L is a generic tag understanding, whereas the T5XXL is the huge model that understands the natural language and author-like sentences. The guidance value here is what controls how much the model will look like its original training data, and the seed string at the bottom here is super important because this tells the model what specific seed to use. If you're not sure what that means, I'll give you an example. If you've ever heard people say we don't know how these AI models work, and every time you get something different, that's what this seed does. Much like a real seed that you can plant, and every plant that grows is unique, every seed is unique. Even though you may plant a bunch of tomato seeds, each tomato that eventually grows from that plant will be a different and unique tomato in itself, and that's because every tomato seed is also different. So a cool trick though with AI is that we can actually use the same seed value to produce the same exact image, which is not something that we can do in the real world. We can't use the same exact seed to produce the same exact tomato over and over again. Now, the reason why this is important is because this is especially helpful when you want to tweak an image that you like later on in the workflow. So that way you're not generating something completely new, and instead you're generating the same thing over and over again based on something that you like. By default, I'm going to leave this set to randomize because we don't have a generated image that we like yet. But later on, whenever we are working on a specific image, then I switch this over to fixed, and I make sure that I leave those to the same exact values. The next part that we have over here is the sampler setting, and these settings you could really geek out about, but I'll give you the settings that work 90% of the time with Flux, and that is Euler, simple, 25 steps, and depending on how you're generating your image, if you have a reference image, you want to have this value set to something below 1 but above 0.5, which means somewhere in between 50 and 100%. The way that these AI models generate images is that they remove noise over time, and having a denoise value of 1 or 100% means that all of the noise will be removed until an image forms. This is really great if you're starting with a blank canvas, but if you want to use a reference image, then changing this value to 0.5 will actually let the reference image drive the generation about 50% of the way, and then the AI does the rest afterwards. This is especially helpful if you want to match the likeness in a pose or color or styles and more. So I'm going to go ahead and queue up this image compare node here, which is going to run all of these nodes in sequence, and you can see it happening both here in ComfyUI and then also in the command prompt. Next, we have the image compare node, which takes our input reference image and our generated image and allows me to simply slide left to right to compare how these two look. Now, as you can see with the denoise value at 0.5 and using the control net depth, some of the features are actually lost, but we retain a lot of the referenced image details, down to where even parts of the background look relatively the same. I gotta say, this is an impressive result. Another really cool thing that we can see here, since we use the reference image, it can take even this noisy looking section here from the reference, which does not have that much detail, and actually go in and use the Flux model add-in details to where this section looks so much more impressive. Not only that, but we also get all of the rain details, and this is looking awesome. Now, of course, some things are pretty weird, like the hair is very wonky, and we can also see that some strangeness is going on here, but that's just a matter of then changing some of these denoise values. So let's go ahead and change this to something like 0.95, and then we're going to go ahead and run this again. Now, already you can start to see the image getting generated, and since we've raised the denoise value to about 95%, we're taking away most of the reference image, and instead we're generating a lot more of the image here in this one. As you can see, the result is that it looks much more like myself and much more like Chriselle. Now, of course, this is still a quick and dirty rough version of it, which is why we have this entire section here on the right hand side, which is all about fine-tuning this specific generation. So remember how I mentioned that seed was going to be a huge deal? Well, that's exactly what gets ported into here. We have the same seed value. We also get all of the same exact generation settings that were used to generate the first image, except this ultimate SD upscale node works by breaking down the image into multiple tiles, and then it works on each individual tile before combining them all together to make a better and larger image. So let's go ahead and queue this one up. And here you're going to see on the sampler custom advanced node that we get a very rough preview of what the final generated image is going to look like before it gets finally sent over here. And here is a quick preview of what that tiling looks like. So this node actually takes in an upscale model. There are a bunch of free upscale models, but the one that I prefer to use recently with Flux is the 4x Foolhardy Remacry. Now, these are all set to mostly their default settings, except for the CFG value is changed from 8 by default to just 1, and that's because Flux is a little bit weird with CFG values. Something particular that you don't really have to understand too much, except that changing it to a CFG value of 1 is essentially turning it off in this scenario. Now, depending on how fast your computer runs, this could take either a few minutes or under a minute. I'm running on an RTX 4090, so the whole process from uploading the reference image, loading in the models, loading in the LoRa's, creating the depth preview, and then applying that control net to the actual generation, all of that typically happens within 30 seconds for the first generation. And then the final section here where it comes down to upscaling the model takes a little bit longer at almost a minute or a minute and a half. And this is what the final upscaled version of this one looks like. We can go through this very slowly. You'll start to see some of the details as we scrub across. So let's take a look at some of these hair details, which already, I gotta say, looks amazing. But as we scrub through, you start to see all of the details come into much more focus, down to where even the leather texture on this jacket is coming in, and we get parts of the rain reflecting off of it. As we keep scrubbing through, we start to see again more of those details just coming in. And if you take a look at this hair pattern, this is probably where I became most impressed, because this actually looks like my hair pattern structure. This is crazy. So as we keep going through, we have a very, very awesome, sharp image. But you may notice one thing that is still wrong with this, and that is that the faces look a little bit weird. They look highly processed, and as you can see here with this eye, what is going on with that eye, right? That looks extremely wonky and does not look good. So that's why we actually have this last and final step here, which is our face detailer. And so what this face detailer node is going to do is it's going to take that image, look at the overall composition, and then load in these segmenters, which is the B-Box, Face YOLO, and Person YOLO models. And these ones are going to be able to identify all the faces, all the people, mask it out, then regenerate the face and stitch it right back onto that same photo for a final step. But there's one huge detail about using the face detailer, which is actually why you're not seeing anything here right now, and that is it does not like to work with the depth maps. So each of these different nodes essentially does something different to the generation process, and they each require their own specific inputs and outputs. And for some reason, in some variants of this generation, you'll end up where it just will not like using the depth map because the sizing and the tiles of it is not divisible by 2. So one trick that you can do to get around this, if you're starting to notice that you're not able to actually apply a depth map and use a face detailer, is to just turn off the depth map once we have a generated image that we enjoy, and then we can actually drag in our generated image as our reference input image. So here is what that looks like when I drag it in, and now we have the image that we generated and upscaled before driving the next generation after it. And because we generated this image with Flux, for the most part, it's going to come out in a value size that is going to work with the face detailer as well. Let's go ahead and run this through, and not only are we going to see the faces get detailed even more, but since we're running this through the process essentially twice, we're going to see more details getting added and a lot of the things getting fixed in the second run. And since we're using a reference image, we want to actually make sure that we're keeping the same composition and most of the elements the same. So for the denoising value, we can actually lower this back down to something like 0.5, which will give us roughly the same image that we fed it in the first place. So let's go ahead and hit Q and see how this comes out. And this is the final result. So here we can see the reference image compared to the initial generation. And then the next section here, we can see it getting upscaled and a lot of these details getting added in, but a little bit of that weird eye wonkiness going on there. And then here at the final section with the face detailer, this first identifies people in the photo and then focuses on the faces. So here you can see it's actually cropped out my face and it's cropped out Chriselle's face here. And then it regenerates that image and plops it right on top of the initial upscaled image. And if I was to scrub through here, you're going to see how even though the image looks pretty good, once we zoom in, it's starting to look very weird until the face detailer comes in and actually fixes all of those messy details. So here on the pupil, we can actually see an individual eyelid and the iris start to show up, as well as some of the details on the lips. So it no longer looks like the lips are merging into the cheek there. They're their own defined structures, and it does keep the hair patterns and a lot of the greatness in the original photo there as well. So this is how we went through each of these images, not just for the Batman generation, because essentially I could go in, pick any reference image, and then by changing the prompt, we'll have a scenario with us in a completely different scene. For example, here I can go ahead and turn the denoise value all the way back up to 1. So instead of having us in a cinematic photo where you can pretty much tell it's AI, let's actually try to just make something a little bit more believable. So let's do a selfie photo of a black man and a Filipino woman, Nate and Chriselle. Nate and Chriselle are in Paris, France. So let's go ahead and see what that looks like by hitting Q. And here we're starting to see the faces showing up, and this is looking pretty good. I think this photo definitely looks like we were on vacation. Another cool thing that you can double check is if you look in the background, we're also seeing that the individuals are either blurred out, but they're also not entirely the same person either. So we don't have overtraining in the model. One thing though that you may notice is that once it does run through the ultimate SD upscaler and then the face detailer, that it may go back and actually make every person's face whatever lore you have. So I would recommend you turn those off if you're doing a photo with a bunch of people in the crowd. Another cool trick, if you wanted to generate a photo with people and have multiple people in the background like we have here in this Paris example, is we can actually drop in that same image as a reference image, open it up in SAM detector and give it a couple points and then click detect. What that's going to do is go ahead and quickly create a mask. You can go ahead and hit save to node. And then if you wanted to clean it up, you can right click on it and open in mask editor, which is a really awesome feature and lets me just clean up this mask super quickly. And then I can hit save to node there as well. And now if I go ahead and turn off our Nate and Chriselle Laura and just leave on this realism Laura, I can probably keep in the same exact prompt and just make sure to use this mask now for the generation. And what that's going to do is only regenerate the background. So here I'm going to change the denoise value to 0.5. That way it does use part of the reference background here. And then I'm going to go down here to all this mess, which lets me select which latents to use. So I'm going to use one that lets me use the mask. And I believe that is this one on input 1. Okay. And then we can go ahead and hit Q again. Now, as this starts to get generated, you're going to see only what was masked out is getting generated. So we need a way to invert this. And we can do this actually with, you guessed it, another node. So let's use a node called invert mask. And then if I drag in the mask from earlier, connect it here through these wires, and then hit Q again, we should get an inverted mask now, as you can see here on the preview. So now what you're starting to see is that we only have the background getting generated and we have our original characters kept the same. So here you can see now it compared to its reference, and just like that, we're able to change the background to various people while keeping the same two people the same. Now, one huge issue with this workflow is that it does require you to train a LoRa, which means that you're going to have a lot of training data to begin with. But there is a solution that is coming down very soon, and we're actually working on it. It promises to be able to take one image and allow you to do exactly what you're able to do with the LoRa, but without having to train a LoRa first. We're still working on it, but we're going to be releasing that video soon, so make sure you guys hit that subscribe button so you don't miss out when it comes out. As you can imagine, ComfyUI can get really awesome with custom and creative workflows, and it really puts the power back in when it comes to using AI. We have this uploaded to our Patreon. I will say some of our other ones get pretty crazy, like this one where you can use your own webcam to animate images. And yeah, there's a whole bunch more. Anyways, thanks for watching. Hope to catch you in the next one. All right, peace.